You're listening to All Things 3D, where we talk about the world of fabricating, designing, and capturing in the third dimension.
Well, that didn't work out. Okay, well, I'll go ahead and introduce you, and then we'll play it a little bit later. So hi, this is Mike Balzer from All Things 3D, and there we go, bring up my camera. And we've got a special guest today, and that is, geez, and I've already lost my little thing for you. We originally were going to get Raul, but we've actually got there, as I call him, the chief technology, and that would be the guy in charge of tech out at eora, how do you pronounce it? Eora, geez. Okay, I'll let you pronounce it. And essentially, this is a very unique little application or device that allows you to do 3D line scanning. And so why don't you go ahead and introduce yourself and kind of tell us a little bit about the company.
Right. Well, I'm Asfand Khan. I'm actually the sort of CTO or guy in charge of tech at eora 3D. And just like Michael said, we basically build a 3D sort of line laser scanner that is powered by your smartphone. So what you do is you basically bring any sort of modern smartphone to the device. It all pairs via Bluetooth, and basically it'll use the camera on the smartphone to essentially analyze the laser, just like a typical line laser does, as it scans across an object, and basically rebuild it in 3D. So the advantage is, of course, that you have the flexibility and the ease of use of a smartphone coupled to a device which can scan things to very high precision.
Okay, and as you can see on your YouTube video, or not YouTube, your website, which I'll come back to in just a second. We'll go ahead and leave that. So as you can see here, prominently on your website is this canister that seems to have some type of latching mechanism to an iPhone. And, you know, currently, I mean, you're showing an Android. From what I read, you only, at this particular point, have iOS, but will this be available on Android at the point of your launch?
Yeah, absolutely. So the one of the reasons why we're specifically sort of starting with iOS is, and this will probably sort of, we'll probably talk about it a little later on as well, there is a lot of data to process when you're doing a sort of 3D scanning with the laser. And, you know, if we're talking about, you know, typical smartphone cameras, 8 megapixels, you know, that's 8 million points and above that you have to process in real time. And so there's a lot of heavy sort of hardware optimization that we do specific to the sort of the processor on the phone itself. And so with iOS, it's just a lot more consistent across multiple devices. With Android, of course, you get sort of differences between the different manufacturers. And so what we've essentially done is we've got the base algorithm essentially all done, you know, for Android. That's no problem. But we just want to know what our customers, you know, what are the most popular phones that they're using, and then we'll basically start optimizing for those ones in the beginning, and we'll just keep adding phones as we go along. So it's really just a matter of optimizing for that specific phone. In terms of getting Android running, it's actually not too much of a problem.
Okay, and actually, I want to talk a little about your software development. Again, as I mentioned, I do have a little bit of background in this, so kind of like to know the libraries you're working with, and actually working with iOS myself, I can see the advantages of working with that platform first. All right, well, why don't you tell me a little bit about your team? Obviously, there was supposed to be somebody else here besides Asfand, but obviously busy doing something else. So how many people are involved in this little project?
It's just 3 of us. So just me, Rahul, and Richard. You'll see him sort of in the background sometimes. So there's just 3 of us. We are essentially sort of friends from high school or university or college, as you probably say there. And yeah, so it's a very small team. We sort of everyone does a mix of different tasks. But you know, I tend to take care of the technology side a little bit more than the others.
And that's why you're called the guy in charge of technology. I like that, Ty. I think I'm gonna borrow that now.
Sure.
Oh yeah. I'm obviously very aware of small teams, like I'm a team of one.
Yeah.
So I know what that, you wear multiple hats in this kind of business.
Yeah. Yeah.
All right, well, I now have the video back up and running. So if you're wondering, audience, why I'm a little bit discombobulated, I closed out the video because it didn't move over. So I'm going to go ahead and play it now. And let's see how this works out now.
Well, eora 3D is actually a 3D scanner that's powered entirely by your smartphone. The eora 3D communicates to the phone via Bluetooth 4.0. I have one here with me right now. So what it does is it connects to your smartphone via Bluetooth. It uses a green laser in the unit to scan across an object, and then using the phone on the camera, it'll analyze that laser and reconstruct the model in 3D. The eora 3D also comes with an accessory. It's a Bluetooth turntable. It'll connect your phone via Bluetooth, and it'll turn your objects while it scans, so you can get all the angles of the surface. You can scan anything up to 3 feet by 3 feet. You can even scan bigger than that. We'll have to stitch it together in software. We include an app which you download to your phone, and that app is totally free. That app will allow you to take scans, share your models, edit, and also stitch models together. The eora 3D scanner is going to be launched on Kickstarter in 2 weeks' time, around October 5, and it'll be starting at $199.
Okay, well, that was actually at Maker Faire in New York, correct?
Yep, that's correct. We actually
just
we're based
finished
out of
that, huh?
So it's a bit of a flight.
Yeah, I can imagine. Well, I really appreciate you just saying, hey, we got finished with that. We're back. We haven't slept, but we're going to come on your show. So I really appreciate that. Looked like I was sighting. Looked like a nice day, too. I was a little surprised.
Yeah, exactly.
I said, wait a minute. Is that San Mateo, California? It can't be New York. So it looked like it was a nice day.
We were actually very surprised about that. It was actually perfect weather. It was like just literally T-shirt weather. You didn't need anything else. No rain. It was awesome.
Wow. That sounds really good. Okay, well, let's kind of get into it. I'm going to bring up myself here, and I'm going to show you kind of a progression that I went through, and to let you know how important this is to 3D scanning. Okay, this right here is my first entry into it. This is a little kit that I had developed myself. You know, it's basically an Arduino system, has a nice little Logitech webcam. Has red line lasers, but I also came to the conclusion, why aren't we using green? So I have a pair lined up, but I realized that the libraries that I was using, again, I was using a Macintosh. I'm trying to remember, it's the OpenCS libraries, which is, or the OpenCV, the computer vision library. They're slow. So essentially you take a whole bunch of pictures and then you analyze them in order to come up with the line deformation. And I have a feeling you probably did something similar to that in iOS. Okay, now let's move on to a more professional version. And you're probably familiar with this because they're probably the most competitive in this market, and that is the Next Engine. And this is an earlier model. I have both the Next Engine SD and HD. Which is this unit here, which uses a series of line lasers as well, and also a webcam. Now, the earlier version had a, what do we call it, a lower CCD element cameras, the line lasers, and then it also used fluorescent tubing to illuminate the object. And that one sells for about $3,000, but after you buy the software, it's more like $7,000. So again, I'm going to come back to the impact of your unit, which is this. This hooks up to your phone. I'm assuming it has a rechargeable battery in it. As you mentioned already, it works on Bluetooth, and you can probably put this in your handbag because, you know, I think men should carry handbags. I do. I got too much. Let's call them gadget bags. But essentially, this will just, I mean, I saw this for the first time. As you know, I said, man, these guys have it. I want one of these because, you know, you can only do so much. As you know, as I mentioned earlier, plus my audience, you're aware that I've done a lot of work with the structure sensor, try and pretty much eat everything out of it, but you still can't do the same thing as a line laser, especially with static object. And to find out that you can do a 3 foot by 3 foot volume, and as you said, even increase that depending on how you want to mount this thing, I think is extremely important. The fact that you're using a green line laser, and as we both know, that's the sensitivity sweet spot of most of the CCD and CMOS imagers, which is built into the phones, and also less noise. And seeing some of the results at least from the videos, and let's see if we can scroll down a little bit, is just superb. Here's a little video that is scanning. As you can see, it works like a lot of the line laser scanners, except it's just that small tube. But the important thing, and again, I'm doing all the talking here, and you can just tell me to shut up when I've said that you don't agree with, because you're using the high imager in these phones, in the earlier 6 and the 6 Plus, it was an 8 meg, but now with the 6S and the 6S Plus with its 12 meg, plus the higher images in your Android phones, this is probably where you're really going to be able to push this.
Absolutely. Yeah, just to pick up on one point, it is there's no battery inside it. It is sort of, you just plug into sort of a wall wart, or whatever you want to call it. But it does run off 9 volts. We did that.
Okay, so it is 9 volts.
We did that very deliberately because that is, of course, generally the easy voltage for rechargeable batteries. So
okay, well, normally, yeah, in my case, it's been 7.5. But you know, I was hoping it would be 5 volts with maybe a micro USB or a USB-C, because then you could hook up all these type of batteries, which is what I've been working on in my design.
Yeah.
So now you see, now you've given me a design. I like to build accessories, so I'll just create a step-up circuit so that you can use a lithium, you know, those portables that you can buy for like $30 to $50, and then completely have a portable system.
Yeah, yeah.
But regardless,
I think we've got we'll have everyone covered there. Just not yet. We've got something in the works there. So so basically, it's just as you said. It uses a green laser, and it's just as you again mentioned. What people don't realize is that whenever you have a camera, for it to pick up the red, green, and blue, which sort of makes up all the colors that we see around us, you've got to sort of divide a pixel into the little mini pixels, sort of a mini red one, a mini green one, and a mini blue one. And the human eye is actually twice as sensitive to green than any other color. And so for cameras to accurately reflect that, they essentially have twice as many or twice as much surface area dedicated to green as to red or blue. And so what happens is that when you're obviously projecting light and like a laser, by using a green laser, you're directly interacting with those particular elements of the sensor, and so you essentially get twice the sensitivity. So what does twice sensitivity mean? If you have a dark object or dark color, for the same power of laser, you're essentially getting twice as much light being detected. So it's easier to scan darker objects. Or let's say you're in a very bright environment. Again, for the same, I mean, we could use a crazy powerful laser, but then, you know, people would, you know, injure their eyes. So for the same power, you know, eye-safe laser, again, you're getting sort of twice as much light back. And so you pick up, whether it's a darker color, whether it's in a really bright environment, you just capture more data, essentially. And then also going back to your point on sensitivity, just sort of a bit of a side issue, like if you look at sort of the top-end 3D scanners, and they use sort of you know, high-end industrial CCD cameras, the big thing there is surface area of the sensor size. So pixel area. The bigger the pixels, the less noise you capture, and when it comes to scanning, even the tiniest noise in the image can create distortions. And so again, by using the green spectrum, you've got twice the surface area compared to red or blue on that particular sensor. And so again, you get a little less noise, you get a better sensitivity, and so a better scanner overall. The only downside to that is that green lasers are expensive. They're not as sort of cheap and cheerful as red, and so they are a little bit harder to find a really good.
And they're not as efficient.
Yes, they aren't. There's a next generation of sensors, actually, lasers coming out now. A lot of the older ones were the sort of the crystal based. So you have this sort of the two crystal sort of frequency doubling lasers, they call them. And now we've got the direct diodes coming out. So they're a lot more compact. There's a lot more sturdy. But yeah, they're a little bit pricey. But we like to use good quality components.
Well, let's kind of get into it a little bit.
Yeah.
I'm actually getting some feedback now. Are you hearing double feedback as well, or just
No, I'm hearing fine. I'm hearing
okay.
fine.
All right. So I may pull out my earplugs, so I won't hear myself, which means I won't hear you. So I'll just have to wait till your lips are moving. So let's
Okay.
get on to one of my other questions here, which is, well, obviously there's a reason why you're using the smartphone camera. We kind of talked about it or touched on it.
Yeah. Yeah.
What else? Why a smartphone? Why not just directly to a computer or your own CCD camera?
Got it. Well, just to give you a little bit of a history on this and sort of why we ended up here. We were actually working, Rahul and I in particular, we were working on another project where we had, maybe some of your viewers are familiar with the concentrating photovoltaics. Basically, you get like sort of a large dish or a mirror, and you sort of focus light onto a really efficient solar cell, and then you use that to convert to get electricity, hot water, whatever it may be. And so we were working on a similar project, and we essentially had a parabolic dish that was made for us. Now, after receiving the dish, the unit, and there's quite a bit of tracking. You have to track the sun, etc. It wasn't working properly. And after a lot of trial and error, we basically worked out that the dish itself wasn't to specification. It was basically a little bit warped. Now, that would not have been a problem if we could measure that warpage. So if we could measure that warpage, we could sort of take that into account, and then we could sort of work our way around it. But of course, it's a parabolic dish. It's not something that you get a set of calipers or a set of ruler and sort of measure it with a straight line. It's a curved surface, and you need to measure that surface. And 3D scanning is pretty much the only way to go. Now, we had a sort of manufacturing expo actually in town at the time, and so we went there, and obviously you have all sorts of equipment there, and 3D scanning was one of them. And the cheapest solution we could find was 20,000. 20,000, and as usual, it's plus software. So we couldn't afford that. Plain and simple, we couldn't afford that. It was really nifty, really nice, really cool, but we just can't afford that sort of scanner. And yeah, so basically what happened was we sort of said, okay, look, we let it go for a while, but we had to solve the problem somehow. We couldn't get around it. And so we looked online. There's a few open source things, OpenCV, as you mentioned, PCL, Point Cloud Library. And yeah, we basically sort of hacked something together. So what we did was essentially we created something very similar to what you have with your first prototype. It was actually 3D printed on shapeways. So we took a video. Yeah, we basically took a video with the smartphone camera. We had a line laser, again, all Arduino powered, just scanning across the object. And then we take that video, we built a Python script, which would essentially take that video and then sort of split all the frames out of it and save them as individual shots. Mm-hmm. And so we took about, I don't know, like 7 or 8 gigs worth of individual photos. Then we built another algorithm, again in Python, that would then pick up those photos individually and analyze them. All that took 4 hours to do. So we do a scan, put it on the computer, and 4 hours later, we'd have a bit of a result. And just continuing to work on that, we improved it to a point where we thought, you know what, this is actually something that is a real need. We needed it. And especially with the rise of 3D printing, a lot of other people want to sort of scan objects around them. They want to sort of, whether it's copying things, whether something's broken, something's missing, scan objects in and then sort of 3D print them. If you want to model them, CAD model, animation, whatever it may be. But 3D scanning itself is a rather important tool to have.
Well, I agree. And geez, Google does that to me sometimes.
Do I need to adjust anything on my end?
Video. But sadly, I can't hear myself, so that means I'll hold out to hear you. I totally agree with you, and obviously, it's the need to satisfy one's own needs. In the case of you providing your own scanner, but it's funny that you mentioned the number 20,000, That seems to be kind of the sweet spot in the higher end 3D scanners.
Yeah.
And I think, like you, and that's one of the reasons I've been working with this little device and my little lens system, which I have here, called Four Eyes. I'm able to provide also decent results, but
Yeah.
you know, it uses a different technology, and you have to have a combination of the two. So
Yeah.
one of the things, as you mentioned, you were talking about software, and I'll jump to my screen here. You
Yeah.
also offer, you know, the other part of this, but that's software to be utilized both in iOS and Android. Now, working in iOS myself, one of the things that I found to be advantageous is using Metal. And for those of you who don't know Metal, that is the new libraries that kind of get you away from using OpenGL and using their own libraries. And now that's good for showing mesh viewing and things of that nature, but you can also use that in some of the other OpenGL functions. So have you moved in that direction with that and use that efficiency? And then the other question that I have is that, you know, with these smaller mobile devices, you have a limitation on memory.
Yeah.
Now that's not as much of a problem in the newer phone that just came out by Apple, which I just purchased for that reason. It now has 2 meg, even though they said, is it 2 meg or 2 gig? You didn't need that, remember? You don't need any more than 1 gig of information memory,
Yeah.
but now that seems to have changed. I'm glad, because actually if you're using VR, which I am, it actually has come in handy. So have you found that as well, working in a more finite, smaller system, that you've had to do some tricks?
Yes, definitely. So what happens is, the questions, sort of leading on from the previous question of sort of why the smartphone. Well, smartphones, if we were doing this, let's say 5 years ago, yeah, it actually would not be possible. Phones weren't capable enough, the cameras weren't good enough, the connectivity simply wasn't there. But what's basically happened is, when people ask the question, well, why not a computer? Why not a webcam? Why not all those other things? Well, smartphones have essentially become that. They've become incredibly powerful sort of computers, you could say, in your pocket. And they already come with a camera, and most likely that camera is significantly better than any webcam that you could possibly buy. I mean, Apple and in particular is very, very pushy on that. They want to make the best camera on the smartphone, period. And so when you have a great camera, a very capable processor, that's basically 2 out of 3 components. The third component that you need for a scanner is essentially a source of light, like a laser or a projector. And so when you're carrying 2 of those 3 components in your pocket, everyone has one, it makes perfect sense to essentially use that. It reduces cost, it makes it easy to use, and of course it's challenging. That's why sort of no one else has done it so far. But that's the problem that we want to solve, and that's where it sort of jumps into the software side of things. When we first started, it took 4 hours on a computer to process all the data, and now we do that essentially in real time in about 2 minutes on a smartphone. And where that's really come from is the optimization, like you said. Metal is Apple's, for those not familiar, OpenGL ES is the old way of sort of displaying, as you can see on the screen right now, displaying sort of point clouds or meshes or whatever it may be. And Metal is Apple's own sort of way of giving you direct access to the hardware. And so what it means is that when we first started, we had a bit of OpenCV, PCL, but they're simply too slow. They're very generic. They're designed to sort of process any sort of data in any type of environment. But when you're building a scanner, then and you're building the hardware, the electronics, everything from the ground up, there's a lot of insight that you have that that only a custom algorithm will be able to do. And that's what we've done. Is we've built everything ourselves from the ground up. We use a heavy amount of GPU acceleration, and that's essentially where the speed comes from. That's why we can sort of store data in its most raw form, process straight from the camera. We do not save any images. We just process in real time and discard, take another shot, discard, process in real time. And yeah, we use a lot of sort of GPU acceleration, you could say, to handle all that data.
Well, and it actually shows in some of the demos that I'm looking at here. So on that note, obviously you are using some of the streamlined functionality. Let me scroll up the screen a little bit. I mean, here you have a lot of icons. Let me see where it's at. Kind of telling or identifying what will be available in this app. If this is true, are you planning to offer this app as a separate add-on to anybody else? Let's say you want to bring in an STL or an OBJ. I mean, these look like tools that would be very useful on, let's say, on the new iPad Pro or something like that. So
Yes,
hopefully you're thinking in that direction, because I would love to have these. In fact, I'd like to talk to you later on. Some of these tools would be very useful for my own app, and I don't know if you're sourcing out some of it. Maybe we can collaborate, but man, these look like very cool tools.
Yeah.
Even if I didn't have this little cylinder, these tools by themselves look like a full assortment. So is this what you're going to be offering?
Yeah, absolutely. Look, like I mentioned, beginning, we're a team of three, so it's very hard to get around to sort of everything. But that's essentially. I mean, when we build a 3D scanner, we don't want to just build something which will capture a bunch of points and say, well, here, just sort of do what you want with it now. You can do that if you want, but it really is designed to sort of give you solid, 3D printable objects, and so. You'll definitely need to sort of, having some stitch functionality, some meshing, some basic noise filtering. So these are all, I mean, it's for us as a no-brainer. You have to offer these little tools. As to sort of getting it working in the iPad Pro and stuff, look, absolutely. We are actually aware that these sort of tools are actually hard to find on a sort of a mobile app.
Yes, they are.
That can do a lot of these functions, and so. The big thing for us is that the app is sort of free. We want to sort of put it in the hands of as many people as possible. This is just the beginning for us, and yeah. So at the moment, it's just for the smartphones, but I wouldn't rule out anything for the iPads and the other tablets.
Well, as if you haven't seen the enthusiasm that I have for all this. Maybe if I put a big grin on. Now, this is very exciting. Obviously, you guys know what you're doing. I would love to see this as a separate app. But more importantly, you have this in two colors. And let's see, I guess I can jump back to your first page that shows it as two colors. One is the standard aluminum. And then you also have a, well, what do you call the other color? It's a darker color. Here we go.
Like a sort of gunmetal gray, you could say.
Gunmetal, which would be great. Or what does Apple call their gray? Space gray. So you got a space gray and the aluminum. Oh, so obviously there was reasons for that, and it keeps popping up to remind me, even though I'm in front of it right now. Early bird backer, $199. Am I reading that correctly? $199.
Yes, absolutely.
Wow. Well, I'm totally excited. Now, does that include that little Bluetooth turntable in the $199, or is that a separate?
No, that's basically the early bird just for the scanner. So one thing that we've done from the very beginning when we built the scanner is a lot of other line scanners have the turntable sort of built in, and what that does is basically you're restricted to scanning anything that fits that turntable.
Exactly.
So if it's too big, if it doesn't fit on, whatever it may be, they have only one mode of operation, which is basically put the object on, let it rotate, and that's about it. And so we do not want that. We wanted to be able, people to be able to take the scanner, sort of scan bigger objects, small objects, in sort of hard to reach locations, whatever it may be. So the scanner actually has a tripod mount underneath, so you can sort of take it around with you. And so the turntable is not attached. What that does, you can it's open-ended now. You can scan surfaces, you can scan bigger objects. The turntable really is just there for convenience. If you do have a smaller object, you can put it on the turntable. Again, it's Bluetooth controlled. It talks to the scanner, and it'll automatically sort of rotate and sort of do the stitching for you. What a lot of your viewers may be familiar with is that generally, if you have, let's say, two separate scans, the way you'd stitch them is basically you'd select some common points between the two scans. That'll give you sort of a rough alignment, and then there's different algorithms you can use to sort of find a line from there. But with the turntable, because it's in sync with the scanner, it knows how much it's rotating by and where it's located. You basically avoid that first step. It doesn't need you to give it the guess when it's stitching 2 or 3 meshes together. And so it basically automates the process. You don't have to use it, but it does make life easier. So that'll be a sort of add-on, about $50 extra.
50? Well, sign me up. But let's talk about SDK. Obviously, it appears that, let's say just in the Bluetooth, what if I wanted to scale that up? Obviously, something like that's not going to have the torque to be able to handle, let's say, myself at 200 plus pounds, or even, let's say, anything probably more than a few pounds. But let's say I wanted to scale that up to something that could support 200, so larger objects. Are you going to have an SDK to, if somebody wanted to create a Bluetooth version of that at a higher torque in order to work with your device?
Look, at the moment, we definitely have plans. We don't have anything sort of coming out sort of immediately. And the reason for that is a lot of this is there's a lot of optimization happening sort of between the system altogether. So from our perspective, manufacturing, obviously we're building the hardware and we don't want to sort of have some fancy pictures there and we can't actually build it. So sort of everything has to sort of tie together sort of to get the price right, to get the functionality right. And so at the moment, even if we, let's say, wanted to sort of, let's say, open up just the turntable part of the algorithm so you can sort of bring your own turntable, there's a lot of software optimization right now where it basically recognizes the turntable and sort of it can sort of know where that turntable is, but that's because it knows exactly how big the turntable is, it knows its dimensions, and so for us to sort of open that up, we'd have to make you tell it how big the turntable is, what its shape is, etc., etc. So we're basically just starting off right now, sort of giving the sort of complete package, but we definitely want to open it up. We definitely want to sort of not just the turntable, pretty much the entire scanner actually. Give people sort of an SDK where they can sort of modify it slightly to for different applications which we may not be able to tackle sort of just yet. And I guess the most common example of that is we get asked a lot, can I scan a room? Can I sort of scan really long range? And we basically say, well, technologically, yes, you can. There's nothing stopping this scanner from doing that. The only issue is that the longer range you have to scan at, the more of a distance you have to put between the laser and the camera. Essentially, we're triangulating here. And so if the object's too far, or let's say it's a room, then the accuracy simply is not there. Now, the easy solution is basically put a bigger mount on it and sort of have the phone, instead of being right next to each other, have them, much further apart. So that's an easy place where someone could, let's say, build their own mount. We'd give them an SDK, and then they could sort of have their own custom scanner, which uses most of our own components, and then they can scan long range. So we definitely want
to. The other issue too is that the laser itself has to be focused with a kilometer as you get further from the object. So I don't know if your laser is focusable or if it's already fixed at a particular distance. So that would have to be a concern as well, is that you would have to be able to tune physically at both ends.
That's exactly why at the moment it's a bit hard for us, even if we wanted to. Really, it's hard to get it working, because even if we did open it up, everything is so tied together and works for this specific type of scanner, for this specific range and quality that we're wanting, that there's very little that you can do. But again, down the track, even from a hardware perspective, this is just our first product, and we want to sort of add more to it. We definitely need to open it up as we go along.
That's why I would just concentrate on this. You guys have a perfect little package.
Absolutely.
There's a lot of people working on large body objects. I think the structure sensor excels at 6 feet. But anything smaller, it has a difficulty, as many structure sensors. So you have a little perfect device here that can support. 3 by 3 is still a large object, and if you can get the detail in you have, in my opinion, the perfect little spot, the perfect price. Okay, one other question before I move on. Well, actually two. One, $199 is your early bird. What's your price going to be if we miss out on that?
So $199 is early bird. It'll be about $250-ish for the Kickstarter price. And I mean, some people sort of ask, well, what's going to be post Kickstarter? It'll probably be close to the $299 mark.
Okay, so $199 if you get in there. How many are going to be available?
That's what we're still literally we're still trying to get a gauge on that as to sort of how many, because obviously we want to offer to as many people as we can. And so right now, I literally just don't have a number.
Okay.
It'll be
date?
Date is, give us about another week or so. It'll be sometime
so
very, very,
maybe next Friday.
very, very soon.
Okay.
Just,
so you will tell those who have signed up.
track.
If you notice, there's a sign up screen behind me. If you
Or
sign
follow
up,
us on
these people will
anywhere,
know, right?
You can find us or sign up, follow us, and yeah, I do not want to just tell people, and so I want to give them an actual date. So we're still locking that in, but very, very soon.
Okay. Well, you got this. You got your sign up here. You can like you on Facebook, and you can also probably go out to Twitter. You'll probably tweet it out. So you'll probably give people ample time, right? I hope
Absolutely.
so. Give me ample time. I would hate to be the one that's been pushing. So one other question, and I'll let you go.
Sure. No.
Do you have an iPhone 6S or 6S Plus?
We have not tried with the 6S or 6S Plus just yet.
Well, get one to me. I'll try it. But I'm hoping.
We got to sort of tweak the algorithm a little bit, especially because we're getting essentially 50% more data now.
Yes.
People sort of get a bit surprised by that, actually, but we actually process at the full resolution of the camera. So all our processing in the background, which the user doesn't see, is all done at full resolution. And the way it works is basically we take sort of full frame shots with the camera. It doesn't get saved. Some people ask, well, if you take like more than 1,000 shots, is that going to kill my phone memory? It was like, well, no. What we do is we take a shot, we intercept it before Apple does anything to it. So the integrated iOS, before it does any compression, before it does any sort of saving, we sort of take that raw data and we process it, and then we sort of discard that. Even then, we're getting from the 6 to the 6S, we're getting 50% more data. So we just got to test everything first. But
yeah, the good thing is you now have the A9 processor, which has about 50% better performance. And as I talked before the show, you now have 2 megabits. Is it 2 megabyte or 2 gigabytes worth? 2 gigabytes worth of internal memory now to work with. So I think the combination of those should give you better performance. As I said already, my hand's up if you need somebody to test it on my end. Right here. Got it right here. Not kidding you. 6S Plus.
There we go.
And already been testing it with my own stuff, and it does provide better performance. So hopefully you can get your hands on one. I can tell you right now, they should see some better performance with it. This is kind of like my imagination run wild. I'm glad that you've come out with it. I'm going to pop back to the screen here, let people know. It's eora 3D. Asfand, can you go ahead and pronounce it again? Eora
3D.
Euro 3D. There we go. And go out to euro3d.com, and you'll be able to sign up, take a little bit more of the information, but I think we pretty much covered everything that this thing can do right now, but I'm assuming it'll do a lot more over time. And back these people up. They've got a cool product here. Now, you guys are out of Australia, is that correct?
We're out of Sydney, Australia. So it's a bit of a distance away. Yeah, we're actually the Eora 3D. The Eora part is actually sort of an Australian word for "I'm from here." I'm
sorry. I'm from what?
I am from here. Basically, it's basically the local Aboriginal language.
Excellent.
It basically I'm from here. So yeah, so the name has a bit of Australian in it as well.
Excellent. Well, I really appreciate it. I've interviewed a few people in Australia, and you obviously, it's a worldwide phenomenon. There's a lot of people involved in 3D, both scanning, tangible object creation, printing, fabrication, and design software. And it's, I picked a perfect time. This is our 2-year anniversary as well of All Things 3D. And I'm glad to be able to cover this. And again, if you want to pop on either as a guest crasher this Friday or next Friday, if you plan to launch at that point, you're welcome to come in. I'll send you a link out to it. And you can just pop in for a few minutes and say, hey, don't forget about us.
No,
and I'll do
absolutely.
what I can. Actually, maybe I don't want to promote it too well. I'd hate to be the last person to get one of these. Oh well.
Uh,
Well, again, thank you. And I guess one other question: if we do
yeah.
sign up for it, obviously I don't think you're going to have any issues having this funded. When can we expect one?
So basically, we intend to deliver around June next year.
Okay,
So
so
if
about 8 months.
yeah, or so. We want to give ourselves, some time. Not that, especially whenever we love going to sort of maker fairs because people get to see it right in front of us. So it's machined out of aluminium, so it's a fairly dense, it's got a bit of weight to it. It's very solid, and that's really for the accuracy and vibration damping. And so people get to see it. Like, look, it's actually there. This isn't a 3D printed prototype. It's the actual machine. Sort of, basically, we've done like a small batch run just to get all the tooling right, etc. So it's there, and we're very we think that we can absolutely nail it in terms of delivery.
Well, the videos which are out there really show that this thing does perform, and I'm pretty excited about it. I don't know if I can wait 8 months. I don't know. Can I give you $500? No, just kidding. My wife would kill me. All right. Well, on that, Asfand, I really appreciate you coming on. Obviously, you guys are probably still hyped up from the New York Maker Faire. Hopefully, you can make it to the San Mateo Maker Faire as well. I'm probably going to be covering that as well. So again, thank you. And this is All Things 3D. Yeah, that's me. And
There we
my
go.
friend Asfand. And on that note, I'd like to say thank you. And join us this Friday for another episode of 3D in Review. And I don't know who our guest crasher would be, but love to have you guys back. So thank you. Bye.